Hello everyone. Today we are starting area under the graph. In our previous discussion, we discussed about integration. So integration is the process of adding small changes. This topic area under the graph is related to integration. In integration, we add small changes to get total change. For example, when we talk about time, so we know that the time increases. So the increase in time, that is also known as duration of time, as delta t. So this delta t means it can be 1 second, it can be 0.5 second, it can be 2 second, 3.2 second. So this is known as duration. Duration or change in time. So time is increasing, but when we say a small change in time, it is dt. This is small change in time. This is a small change in time. This is also known as instant. Dt is known as instant. So when we add all the instants, we get total change in time, that is duration. So adding all instants becomes duration of time. Instant means small change in time. Small change in time. So suppose if we draw a line representing time axis. So this line is representing time axis starting from t is equal to 0. So let us say this is t is equal to 1 second and this is t is equal to 2 second. So point A to B, the duration of time is 1 second, but it is made up of very large number of instants. Each instant is dt. So when we add all the instants, dt plus dt plus dt and so on, then we get delta t. So this is also known as integration of dt. Integration of dt becomes delta t. So how we relate these concepts in graph? So we have quantities as x, which is position, and time t. So we have xt graph, vt graph, then vx graph, then at graph, ax graph, av graph. What is the how we apply area under the graph in these graphs? So, or can we apply area under the graph concept in all these graphs, or some specific graphs only we can apply area under the graph? We will see. First, we will see what is the meaning of area under the graph. Suppose we say dx. So, dx can be written as v dt. Here, v is instantaneous velocity and dt is small change in time. Small change in time. It is very small. It is very small change in time, but not zero. But not zero. So we get small displacement dx. Small displacement dx. If velocity is positive, so the displacement is positive. If velocity is negative, so displacement is negative. So suppose let us draw a graph involving v and dt. That means velocity and time. And for basic understanding, let's take constant velocity v naught. V naught is constant velocity. So how is the vt graph? If vertical axis is representing velocity and horizontal axis is representing time. So the intersection point is known as origin. So this origin has time t equal to 0 and velocity v equal to 0. But the given situation is velocity is constant. It is v naught. It can be 1 meter per second, 2 meter per second. It can be negative also, minus 1 meter per second, minus 2, minus 3 meter per second, or minus 1.5 meter per second. So I am assuming it is positive. It is positive velocity, positive constant velocity. That means the car is moving right side, rightward with constant speed. So the graph will be like this. The graph will be parallel to time axis. If we represent two time instants t1 and t2, so the duration of time will be delta t. The duration start at t1, finish at t2. This time duration is the difference t2 minus t1. Suppose t1 is 1 second, t2 is 3 second. So duration will be 3 minus 1, 2 second. Duration is 2 second. If we consider point on the graph corresponding to t1 and point on the graph corresponding to t2. So this is point on graph corresponding to t1 and this is the point on graph corresponding to t2. Let us find this area. So this shaded region is known as area under the graph. This shaded region is known as area under graph. Let's calculate how much is this area. So we have the shape of this area as a rectangle. We can say the height of this rectangle is v naught. This constant velocity is v naught. So it can be 1 meter per second, 2 meter per second, and suppose this length of this graph is t2 minus t1. So the area will be length into breadth, which is equal to v naught into delta t. Now what is this quantity v naught into delta t? In physics, in the previous chapter also, we have discussed in the previous discussion, what is v naught into delta t? If v naught is constant, so what is this? This is displacement. You can call it total displacement also. It can be represented by delta x. So suppose we are writing dx is equal to v naught into dt. So integration of dx will be integration of v naught dt. Integration of dx will become delta x. And v naught will come out because velocity is constant. Now this is v naught into integration of dt, which is delta t. So delta x is equal to v naught into delta t. So we are understanding v naught into delta t using integration. So delta x is v naught into delta t, and using graph we have v naught into delta t as delta x. So the integration v dt, which is integration dx, and integration of v dt, which is delta x, it is area under velocity time graph. Area under velocity time graph. So we can use this concept of area under the graph for velocity time graph. So let's solve one question. Now we have a situation in which the velocity is constant for some time. Let us suppose the velocity is 2 meter per second from 0 second to, let's say, 2 second. And after 2 second, the velocity becomes negative. And that negative velocity is -1. So this is the VT graph given to us. If you observe, 0 to 2 velocity is +2, 2 to 3 velocity is -1. So what type of graph is this? What type of motion is this? We can take example also when this type of graph is possible. Suppose there is a wall and there is a smooth horizontal surface. Smooth horizontal surface. A block is coming. Suppose this is the block. It is coming right side with 2 meter per second. So there is no friction here. So no one is going to oppose this block. So it will maintain its velocity 2 meter per second. Then after collision with the wall, this wall is obstruction. It will not allow this block to cross the wall. So the block has only one option left. It will hit the wall and it will rebound. We are assuming that the collision is not perfectly inelastic. The block is not sticking with the wall. Instead, it is rebounding leftward. So we know that during collision some energy is lost, so it will rebound with some less speed. Say it is going with 1 meter per second after collision. So this is before collision and this is after collision. So before collision we observed the motion of the block for 2 seconds, 0 to 2. So 0 to 2 seconds we observed it. At 2 seconds collision happened, and during collision we see the direction of velocity is reversed. We can take another example also. The ball is dropped from some height, so it is hitting the floor, it is rebounding. So before collision the direction is downward, and after collision the direction is upward. Similarly, this is the wall. Before collision the block is going right side, after collision the block is going left side. So velocity becomes negative, and the time of collision is generally very less, so we are ignoring it. So ignoring the time of collision, we can say 0 to 2 second the velocity is right side, 2 to 3 second velocity is left side, and collision time is negligible. So this is the example which is fitting for this graph. So initial velocity is 2 meter per second. It is continuing for 2 seconds, and 2 to 3 second velocity becomes -1 meter per second. So question says find total distance from 0 second to 3 second. From 0 second to 3 second, what is the total displacement and total distance? So we will find the area under the graph. We have a formula, delta x is equal to integration of v dt. So this is area under graph. Which graph? Velocity time graph. What you see here, v, and what you see here, t. So it is vt graph. Vt graph area will give delta x, which is displacement. So let us find this area. So the length is 2 and the breadth is also 2. So this is 4 meter. So this is positive area. Above time axis, the area is positive. Now the below time axis, the area is negative. Now the question is why? Why this area is negative? Why this area is negative? Because we know that the area under the graph is displacement. So when displacement is negative, we have to take negative area. So let's go back to this example of block hitting the wall. So before hitting the wall, the displacement is positive, and after rebound, the displacement is negative because velocity is negative. So 2 to 3 second, we are observing its leftward motion. It is going with constant velocity of -1 meter per second. So this area will be a minus because this area is negative. So we will put minus sign. Then the length is 1 and breadth is also 1. Now we will take magnitudes here. Magnitude of length, magnitude of breadth. So this is -1. So the total distance will be, now when we talk about distance, distance has nothing to do with direction. How much it has traveled right side, how much it has traveled left side without direction. So how far it has traveled in the positive direction? 4 meter. How far it has traveled in the negative direction? 1 meter. So the distance will be 4 plus 1, so that is 5 meter. Distance is 5 meter. If they ask total displacement, then total displacement will be area under the graph. Take positive area and negative area and add. Positive area is plus 4 and negative area is -1. So 3 meter. Displacement is 3 meter and distance is 5 meter. 4 plus 1. This is one example. Let's take second example. Now we have another graph. Let's take example in which velocity is changing. When we say changing velocity, it can be increasing velocity or decreasing velocity. So we can take example from our daily life also. I will talk about example, but let's draw the graph first. So this is the velocity time graph. When time is 0, the velocity is also 0. And as we see this graph, it is velocity is increasing linearly. Velocity is increasing linearly. Why linearly? Because the graph is a straight line. When graph is a straight line, we know that velocity time graph is a straight line, so acceleration is constant, because we have learned this in previous discussion in the topic slope of a graph. So acceleration is positive and it is constant. So let's take this velocity is 3 meter per second and the time instant is 2 seconds. So 0 to 2 seconds, the velocity increased from 0 to 3 meter per second. 2 second to let us suppose 5 second, the car or any moving object, it is going with constant velocity. Velocity is constant. So it is a straight line parallel to time axis. So 2 to 5 second, it is maintaining constant velocity of 3 meter per second. And let's take uh, at 8 second velocity becomes 0. So 5 second to 8 second, the velocity is decreasing from 3 meter per second to 0. This is also a straight line. So we call it linearly decreasing or decreasing linearly. This is retardation. So 5 second to 8 second, it is retardation. So basically we are applying brakes, and this is acceleration. So suppose you are in a signal, there is a red signal, so the velocity is 0, you are stopped in the signal. Now you see that the light becomes green, so you start moving your car. Then basically you are accelerating your car. Then you see the car has reached the desired speed, so you maintain that speed. But again you see some in a next signal where the signal is green, so now you have to stop there. So you are decreasing the speed of the car, and finally it will come to rest. Now the question is, what is the total displacement? How to calculate total displacement using the graph only, without using integration? So we will calculate the area under the graph. So we have a triangle. This is the triangle. So what is the displacement from 0 to 2 seconds? Let's calculate. So this is S1. S1 will be, now it is a triangle. So for triangle we will use half into base into height formula for area. Area for triangle, this will be equal to half into base into height. S1 is 3 meter. What is the displacement covered from 2 to 5 seconds? So we have to calculate this area. Now it is a rectangle. So this area will be S2 will be equal to length. Now length is 3 seconds. 2 second to 5 second, it is 3 seconds into breadth, which is 3. The height is also 3. You can call it breadth or you can call it height. So this is 9 meter. S2 is 9 meter. Now we have third triangle from 5 to 8 seconds. So let's calculate this area also. So S3, now we have S3 is equal to half into base into height. So the base is 5 second to 8 seconds. So this is also 3 seconds. So we have this as 9 by 2. So this is 4.5 meter. S3 is equal to 4.5 meter. So what is the total displacement? Total displacement will be S1 plus S2 plus S3, and as you observe, all the area are positive because whole shaded region is above time axis. So all displacements are positive. So we have 9 plus 3, 3 plus 9, we have the answer 3 plus 9 plus 4.5. that is equal to 12 plus 4.5, that is 16.5 meter. So that is a total displacement, and also this is total distance because all displacements are positive. So total distance is also 16.5 meter because all displacements are positive. Next, we can also find what is the displacement from 0 to 3 second. Now 3 second is in between 2 and 5 second. So let's take one question in which the time duration is between 2 and 5, or between 0 and 2, or between 5 and 8. Let's take next question. Now it is a VT graph. It is a straight line graph. When time is 0, the velocity is 2 meter per second. Velocity becomes 0 at 2 second. So velocity is decreasing linearly from 0 to 2, and 2 second onwards it is increasing linearly. It becomes negative. After 2 second velocity becomes negative. That means the particle is going leftward. So here the time is given as 5 second. 5 second. Question is find distance from 0 to 5 second. From 0 to 5 second. And second question, find distance from 0 to 4 seconds. 0 to 4 seconds. Let's solve these two questions. When we consider 0 to 5 seconds, we have to cover the whole region. So this region will be positive area, and this region will be negative area because this region is below time axis. So we have to take negative, and we are considering 0 to 5. So whole region we have to consider. Now, so the answer for positive region is half into base into height. So 2 cancel. So this is 2 meter. So the positive area is 2 meter. Now let's calculate the negative area. So we know that the base is 3. Base is 3 seconds. Now height. What about height here? So we can find this. In the question it is not given at 5 second what is the velocity, but we can find it because we need it, because we need height. Suppose the velocity is -1, so the height is 1. If velocity is -2 here, so the height is 2. So we have to find what is the velocity here. So let's calculate the height is h. Then you look at these two triangles. These two triangles are similar triangles. So these two angles are same. Suppose these are theta and theta. So we have this side as 3, this side as h, and this side as 2, and this side as also 2. So tan theta using this triangle is 2 by 2, and using this triangle is h by 3. H by 3. So we have 1, 2 by 2 is 1, cancel. 1 is equal to h by 3. So we have h is equal to 3. So in the question h was not given. This velocity also not given, but we have calculated h is equal to 3. So this velocity will be -3 meter per second. Now let's calculate the negative area. So negative area will be minus half into base into height. This is minus 4.5 meter. So second displacement is negative, first displacement is positive, 0 to 2 is positive, 2 to 5 is negative. So the total displacement will be 2 minus 4.5 and total distance will be 2 plus 4.5, which is 6.5 meter. Total distance is 6.5 meter. So answer to first question is total distance, which is 6.5 meter. You have to consider whole time duration, which is 0 to 5 seconds. How to find distance from 0 to 4 seconds? Let's talk about this. So when 4 seconds is there, 4 seconds will be here. It will be between 2 to 5. 4 seconds will be here. So 0 to 2 will be same. 0 to 2, the area will be same. 2 to 4, the area will be different. Then 2 to 5. 2 to 5, you have to consider this area. So 2 to 4, you have to consider less area. So how much area you have to consider for 2 to 4? Let's draw another diagram for that. Now initial velocity is 2 and final velocity is 0 at 2 seconds. This is 2 meter per second, this is 0, this is 2 second. Now we have here 5 second and here velocity is minus 3 meter per second. Now we will consider the time instant for here, because the question is asking what is the distance from 0 to 4 second. So 2 second here, 3, 4. So somewhere here is 4 second. This is 4 second. This area we have already calculated. This is half into 2 into 2. This is 2 meter. Now let's calculate this area. This area is between 2 and 4 second. From 2 to 4 second we have to calculate area. So for that we need the height again. This height we need. Let's suppose this is h1. This height is h1. Corresponding to this point on the graph, that is at 4 second, what is the velocity? It is not given. We can calculate it. Again we will draw these type of two triangles in which one angle is common. So if you look at this triangle, this is 2 and this base is also 2. If you look at this triangle, this is base is 2, so height is h1. So we have tan theta here as 2 by 2 and tan theta here is h1 by 2. So we get h1 is equal to 2. h1 is equal to 2. So the area of this triangle will be minus half into base into height. Height is 2. So this velocity is minus 2 meter per second. So 2 to cancel. So this is minus 2 meter. So now the total displacement between 0 to 4 seconds, total displacement is equal to plus 2 minus 2, that is 0 meter. Total displacement and total distance will be equal to 2 plus 2, 4 meter. Total distance is 4 meter. So the answer to second question, which is 0 to 4 second, it is 4 meter. This is 4 meter total distance. So we have used area under the graph for velocity time graph.